All right, so in 4.1 we got introduced, well, reintroduced for most of you, back into the trig. We talked about how to graph it in standard form, in standard position, how to convert it from degrees to radians, from radians to degrees, how to find coterminal, how to find complement, supplement, and then conversion and arc length. So kind of this one slide kind of sums all that stuff up. So to graph it, if you look on the bottom, 4 pi over 7 is going to be slightly bigger than a half pi, right? Because a half would be like 3.5 over 7. So it's slightly bigger than a half pi, which puts it into the second quadrant. And then the coterminal angles, if it was in degrees, we'd be adding and subtracting what? What do you add and subtract? If it's in degrees and you're doing coterminal, what are you adding and subtracting? What's a full circle in degrees? 360, good. Because this is in radians, we add and subtract 2 pi, and that's what's over here on the right-hand side. So that ends up being 18 pi over 7 and negative 10 pi over 7. And remember that we talked about that if it's still, like sometimes it's so negative that even when you add 2 pi, it doesn't make it positive, you got to keep going. Then we get into complement and supplement. So the complement is when it adds up to 90 degrees or pi over 2 if it's in radians. So I'm going to subtract from pi over 2 and, oh no, sorry, I subtracted from pi. This one's this one. This is that one, which would be 3 pi over 7. And this one actually doesn't have a complement, right? Because it is bigger than a half pi. If you subtract it from a half pi, you're going to get a negative. That's how you know it doesn't have a complement. So complements and supplements, remember, can't be negative. And then conversion from angles to degrees, you're going to multiply, or 2 degrees, from radians to degrees, you're going to multiply by 180 over pi. This time you got 720 over 7, which is 102.9 degrees rounded. If I was going to convert it back the other way, I'd multiply times pi over 180. And then E was find the length of the arc with the central angle and the radius. Remember that that's theta times the radius, but what has to be special about theta? Has to be in radians. So this one was already in radians. I just had to multiply by 5, and I get 20 pi over 7. You will keep that exact. You won't put that into decimal form or rounded form. You can put it in improper, but you don't need to. I mean, you can put it in mixed number, but you don't need to. This quiz, which is Wednesday, you're going to not have your calculator, which means any kind of question, which we'll get to in a little bit, the ones that have, like where you find trig functions of an angle using your calculator, we'll save those for the test. But you'll get this entire quiz, which is half unit circle, half these kinds of questions, no calculator. So keep that in mind while you're doing. All right, the next one said, this is now from 4.2. So find the point on the unit circle that corresponds to the real number t, and then find the 6 trig functions of the angle. So my point was 14 pi, or my angle was 14 pi over 3, which converts to 4 and 2/3 pi. Remember, the even whole numbers is on the right. So I would start on the right, and then 2/3 is past a half but smaller than whole, which means second quadrant. And there, my x is negative, my y is positive. The over 3s, hopefully you can do a quick recall on those, are 1/2 and root 3 over 2. I know it's a negative 1/2 because it's in the second quadrant. And then our tangent at the over 3s is root 3, which helps you too. So the sine is positive root 3 over 2. Cosine is negative 1/2. Tangent's negative root 3. Cosecant's 2 root 3 over 3. Secant's negative 2. And cotangent's negative root 3 over 3. Questions on that one? So most of you that I peeked out were on the right track. Okay, then came the even and odd functions. Remember that the even functions are cosine and secant, because even if you change the sign on those angles, it does not change the positive negative sign on the trig function. So when I have cosine of t as 5/7 and I ask for cosine of negative t, I do not change the sign. It stays as 5/7. And then secant of negative t would be the reciprocal of that, which is 7/5. What are my odd functions? Sine and tangent, and then their reciprocal functions, right? So if I had given you the sine was 5/7 and then the sign of negative t, you would change the sign on it. Questions on that one? Okay, then came the calculator. So this will be saved for your test if you want to think about planning for future. use the calculator to follow to find the functions, and then round it to 4 decimal places. This was the cosecant of 5 pi over 7. Remember that when you do get to calculator portion on your test, you're going to have to switch back and forth from radians to degrees. You want to make sure that you're comfortable with that. And I also said it last week, but remember that when we clear your calculator, which you'll do when you start your test, what does it put it back into? Radians. So if your first question is degrees, you got to make sure you switch it back. Okay. Any questions overall on either of these? Okay. So 4-3 is right triangle trig. Again, something that you should remember some of it from even as far back as geometry, because it's right triangles, right? The magical word that is SOHCAHTOA, that's in this section. So we're going to learn how to just solve right triangles, and then we're going to learn how to apply it to the angles and functions that we've been using. So SOHCAHTOA is the acronym, which as weird as as popular as it's weird that it's not in your book. Okay, your book actually doesn't use it. But if you can learn how to spell that word, you can figure out all your functions, right? The SOH is for sine equals what? Opposite over hypotenuse. The sine, or the cosine, which starts the CAH, is adjacent over hypotenuse. And the tangent, which is the TOA, opposite over adjacent. So this only works on right triangles because no other type of triangle has that hypotenuse, right? So all of this stuff is based on right triangle trig. And then the reciprocal functions are obviously just the reciprocals of these. So cosecant would be hypotenuse over opposite, secant would be hypotenuse over adjacent, and then cotangent would be adjacent over opposite. All right, so if you look at the little triangle that's there on the left, you've got just a generic right triangle. On the right, put it into the unit circle, which is kind of where the overlap happens. So if I look at the one on the left and I use just the letters that are there, what is the sine of theta if theta is in this corner here where angle A is? What would be the ratio of the sine? A over C. Which means cosecant is C over A. How about cosine? B over C or C over B. And tangent? A over B or B over A. So now the overlap with right triangle trig and unit circle is that all those points that are on the coordinates that we move it around our circle are the x and y values. So the change in x would be the adjacent side, the change in y would be the opposite side, and then the radius itself is 1. And that's where all those coordinate points, all the root 3 over 2 and 1/2, all the root 2 over 2s, all those come from taking a special right triangle and putting it in that circle with a radius of 1 or a hypotenuse of 1. Good so far, yes? Everybody remember this? Yeah, good. All right, so trig values for a given angle are always the same no matter how large a triangle is. No matter what the side length is, if my angles are the same, because these are similar triangles if you remember from geometry, the side lengths grow in proportion. So if this angle stays the same and it's a right triangle, it means that third angle also would stay the same up here. Then these side lengths are always going to grow in proportion, which means I could have a teeny tiny 30, 60, 90 triangle or a huge 30, 60, 90 triangle, and the ratio of the sides is going to stay the same. I could have a teeny tiny 45, 45, 90 triangle or a huge 45, 45, 90 triangle, and the ratio of the sides is still going to stay the same. All right, find the value of each of the 6 trig functions of theta, given that b is 4 and c is 2 root 5. Go ahead and work it out. All right, so you have to do the Pythagorean theorem to find the missing side. Any triangle that you have 2 of the 3 sides, you can use Pythagorean theorem as long as it's a right triangle. So a squared plus b squared equals c squared. The c has to be the side opposite the hypotenuse, but the a and the b are, like, it doesn't matter which order you put those in. So then I'd get a squared plus 4 squared equals 2 root 5 squared. Square both sides, or square both the b and the c, and I get a squared plus 16 equals 4 times 5, which becomes 20. Subtract the 16 and a squared equals 4, and then a equals the square root of 4. Technically, a equals positive and negative square root 4, yes? But why do we ignore the negative?
So it can't be negative.
Good. A length can't be negative on a side, right? So I would do positive 2. Now I've got all my 3 side lengths. So the sign would be opposite over hypotenuse, or 2 over 2 root 5, which becomes 1 over root 5, or root 5 over 5 once it's rationalized. Cosine is 4 over 2 root 5, which is 2 over root 5, or 2 root 5 over 5. And then tangent is 2 over 4, or 1/2. So now when I go to find my reciprocal functions, if I could give you a piece of advice, it's flip it before you rationalize it. So go back to the step before you rationalize it and flip that. Otherwise, you're going to be re-rationalizing something you already rationalized. You're doing a lot of extra work. So then for this one, I'm going to go back to before I flipped it, before I rationalized it, which is root 5 over 2. And then for the last one, it's just the reciprocal, which is 2. So when finding something was rationalized, when finding that reciprocal function, go back to before it was rationalized and save yourself the extra work. Questions so far? All right, special right triangles. So there are 2, which is how our unit circle gets formed. Special right triangles that are a 45, 45, 90 triangle and a 30, 60, 90 triangle. These relationships you have to memorize, okay? A lot of standardized tests like to pull these in too. So a 45, 45 is normally just x, and x root 2, but because we're putting this inside that unit circle, we're treating it as 1. So x is 1, 1, 1, and root 2. And then our 30, 60, 90 degrees is normally x root 3, and then 2x, but we're treating the x as 1. So the ratio of sides here is 1. Opposite the 30, opposite the 60 is root 3, and opposite the 90 is 2. Again, 45 is 1, 1, and root 2. Which is where all these functions come from on our unit circle. The sine of 30 degrees, if I look at 30 degrees in my special right triangle, sine would be opposite, which is 1, over hypotenuse, which is 2. That corresponds to the y-coordinate of our 30 degrees. Cosine at 30 degrees would be adjacent, which is root 3 over 2, which is hypotenuse. Again, that corresponds to the x-coordinate on our unit circle. And then tangent is opposite, which is 1 over adjacent, which is root 3, rationalizes to root 3 over 3. So everything that's in this box here corresponds to the coordinate points on your unit circle. If you prefer to set up a right triangle and find your trig functions of the special angles that way, you totally can. If you would rather go unit circle, you could do that too. So it's totally up to you what you want to do, as long as you could do one or the other. All right, so given that, find the cosecant, secant, and cotangent. Since we're in the right triangle trig one, I'm going to show you how to set this up with the right triangle. But again, moving forward, you can kind of choose what you want to do. So if I've got a 30, 60, 90 triangle, opposite the 30 goes what? 1, yes. Opposite the 60? Root 3, opposite the 90? 2. So the cosecant is the reciprocal of sine, right? So if sine is opposite over hypotenuse, then cosecant is hypotenuse over opposite. Secant is the reciprocal of cosine. If cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. And cotangent is the reciprocal of tangent, which is opposite over adjacent. So cotangent is adjacent over opposite. So if I look at angle 30 degrees, which is here, that's my theta. Hypotenuse would be 2, opposite would be 1, and this is 2. If I look at hypotenuse, which is secant, which is hypotenuse, which is 2, adjacent, which is root 3, I have to rationalize that to root 3 over 3. That's the secant. And then cotangent, adjacent, which is root 3, over opposite, which is 1, and my cotangent is root 3. Now repeat that process for 60 degrees. All right, so the cosecant, hypotenuse over opposite would be 2 over root 3, which gets rationalized to 2 root 3 over 3. Secant of 60 is hypotenuse over adjacent, which is 2 over 1 or 2. And cotangent is adjacent, which is 1 over opposite root 3, which becomes root 3 over 3. So because these are reciprocal, these are the complementary angles from your right triangle, these will always be opposite. The secant of one will become the cosecant of the other. The cosecant of one will become the secant of the other. Same for sine and cosine. Like sine of one becomes the cosine of the other, and then cosine of one becomes the sine of the other. And then these two are always reciprocals, which if you compare the coordinate points at your pi over 6 and your pi over 3, you'll see that's the same thing because those are also complements. Questions on those? Okay, again, I don't care how you do it when it comes to quiz time or test time, whether you use your unit circle or whether you use a right triangle, you just got to be able to use one or the other.
For the unit circle, we have to fill it out?
Yeah.
Okay.
All right, so this one says use your calculator to evaluate the function around your answer to the 4 decimal places. So remember, you got to pay attention to what mode your calculator is in. First thing you want to do is look at the questions and say, are they in radians or degrees? What is A in? Degrees. What is B in? Degrees. What is C in? Radians. So remember, even if it's a whole number but it doesn't have the degree symbol, it's in radians. So this, I would make sure my calculator, I would make sure that my calculator is in degrees for that first one, and then it's 1 over the sine of 35 degrees, which is 1.7434. Then I go to secant, which again, this one's in degrees, 1 over cosine, 83 degrees and 15 minutes. Remember that is under the angles menu. So I don't have to convert it first. I can actually type it in just like that, or you can convert it and then type it in. It doesn't matter. 1 divided by the cosine of 83 degrees, which is under the second apps menu. 15 minutes, which is under that same second apps, which is your angles menu. And you get 8.5079. And then cotangent, which is 1 over the tangent of pi over 7. And again, that needs to be in radians. .0765. Yep.
So when you're doing the first two, it has to be in degrees?
Correct.
How do you switch it to degrees?
There's a mode button, and it's the fourth thing on the list. You're welcome. All right, cofunctions, okay? These are another set of you, if you're keeping track of your identities, we did reciprocal identities, we did even and odd identities. These are your third set of identities. These are called cofunction identities. And all it says is basically what we talked about with the complements of angles. A cofunction is a function in which you could find the same value using the complement and the reciprocal, and the cofunction function, yeah. So if I say the sine of theta, I would get the same answer by finding the cosine of its complement. And its complement would be 90 minus pi, or 90 minus theta. So if I asked you for the sine of 30 degrees, a cofunction would be the cosine of 60 degrees, because those are complements, okay? Sine goes with cosine, tangent goes with cotangent, secant goes with cosecant. So these are not reciprocal functions. These are called cofunctions. They are basically the same answer. So whether I find the sine of 30 or I find the cosine of 60 degrees, I'm going to get the same answer. And those are inverted, obviously, because cosine would equal the sine of its complement. Cotangent would equal the tangent of its complement. And then cosecant of an angle would equal the secant of its complement. Those are all given in degrees. Remember that? Radians would be pi over 2. So if I wanted to know the same value of tangent theta when it's in radians, then I would do the cotangent of pi over 2 minus theta. And sometimes you will see it just like that, especially when we get to like verifying identities. You're going to see it just like that. Sometimes it's actually going to give you the angle, and then you need to find the complement. So you need to know sine goes with cosine, tangent goes with cotangent, secant goes with cosecant, and then obviously you need to find how to get the complement. All right, so they look like this. Find the cofunction with the same value of the given expression. So what's the cofunction for cosine? Sine. And what's the complement of 20 degrees? 70 degrees. That's it. So you don't even have to figure out what they are. If you had the calculator, you could find them both and verify that they're equal, but you won't have a calculator on a quiz, so you want to just be able to find it. Cotangent of 40 would equal what?
Tangent 50.
Good. Tangent of 50. So cosine with sine, secant with cosecant, tangent with cotangent, and then the next part is its complement. All right, this one says, use the given function values and the trig identities to find the indicated trig functions. So the first piece of information it gives me is to allow me to set up a triangle. It says that the cosecant is 3 and the secant is 3 root 2 over 4. So if I set up a triangle, let's say I set it up initially off of the first piece of information I'm given, which is that the secant would be 3 over 1, or cosecant, sorry. Cosecant would be hypotenuse over opposite. So the hypotenuse would be 3, and the opposite would be 1. If I look at the second piece of information, which is the secant, this would be the reciprocal of cosine, so this would be hypotenuse over adjacent. But that's telling me that my hypotenuse is 3 root 2. Is that consistent with what we just found? No. So how else does a value like that change?
There's a root 2 on the bottom.
Sure. If there was a root 2 in the bottom, I'd have to rationalize it, right? So let's test that theory out by using the Pythagorean theorem to find the third side of this. So I'd get 1 squared plus x squared equals 3 squared. 1 plus x squared equals 9. X squared would equal 8. X would equal the square root of 8, which is 2 root 2. Now, if I look at this, hypotenuse over adjacent would have been 3 over 2 root 2, which would have been rationalized to 3 root 2 over 3 times 2, which is 4. And then your information matches. So for right now, you actually only need one trig function, and you can fill in the rest using the Pythagorean theorem. Eventually, you're going to need those signs. Like when we move it out of the first quadrant, you'll use those to figure out your positive, negative signs. But for right now, grab the first one, set up your triangle, find the missing side using the Pythagorean theorem. Now, theta's here, so I can find all the trig functions they asked me for. The sine of theta would be 1/3, which you could get from your triangle or from your initial cosecant, because it should be the reciprocal. The cosine I can again get from my triangle, which is adjacent to root 2 over 3. Or I could have also gotten it from the secant by flipping it and re-rationalizing it. The tangent would be 1 over 2 root 2, which becomes root 2 over 2 root 2 times root 2, which is 4. And then here's my cofunction. The secant of 90 minus theta means the same thing as what? The cosecant of theta, which I already have. That's 3. Questions on those? Okay, this one says find the exact values of the indicated variable. So we're going to round this to the nearest tenth because I didn't put it on there, round to nearest tenth. So there will be two types of solving right triangles. One in which you have special angles 30, 60, 90 degrees, 45, 45, 90 degrees, and then the other like this. This you must have a calculator for. If this was a 30, you could do it without your calculator because you'd set up your ratios, which we'll work through in a minute. But the way that it is, you have to have a calculator. So I would grab 32 degrees as my theta. And then there's only one side given, which is that 7.8. So I'm going to use the other sides. Let's say I want to solve for x first. In relationship to that 32, 7.8 is located where? Opposite. Okay, and x is? Hypotenuse. So which trig function involves opposite and hypotenuse? Sine. So I'm going to do the sine of 32 degrees equals 7.8 over x. And then I could multiply both sides by x. This cancels. And divide by the sine of 32. And then let the calculator do that work for you. What mode do I have to be in? Degrees. Now let's say I had started with y. In respect to that 32, what relationship does y have? It's adjacent. So what's going to be opposite and adjacent because I want to stick with what they originally gave me? That's opposite and adjacent, that's tangent, right? So the tangent of 32 equals 7.8 over y. Again, multiply both sides by y. And then divide both sides by the tangent of 32. How could I check to make sure that's right? Pythagorean theorem. It may not be exact, right? But when I tested out 7.8 squared plus 12.5 squared should be pretty close to 14.7 squared. Okay, so let's pretend that, because this I would say you're saving for your test, right? Because we said no calculators. Unless it just asks you to set it up, which is what I think the standardized test would do. If it's a non-calculator base, it would just say, find what is the tangent of 32, and you would set it up as like 7.8 over y and just leave it like that. But let's say that this triangle was a 30, 60, 90 triangle. Or a 45, 45, 90 triangle. These you can obviously do without a calculator, right? So if I said, let's make it a little bit easier on ourselves. Let's just say that was 7, and it still wanted x and it wanted y. The relationship of the 30, 60, 90 triangle is that opposite the 30. Obviously, this is not unit circle based, so this is no longer 1. This would be my a. This would be my 2a. And this would be my a root 3. So 30, 60, 90 is opposite the 30 is your x or your a. Opposite the 60 is x or a root 3, and 90 is 2a. So if I know that 7 is a, then this side would be 7 root 3, and this side would be 2 times 7, which is 14. If I switched it, if I made it opposite the 60 that was given, then I would say that this equals a root 3. This still equals a. This equals 2a. And that time I'd have to divide both sides by root 3. And I'd get a equals 7 root 3 over 3, which is what this side is. And this would be 2 times that, or 14 root 3 over 3. So you got to look at what side you're given. Sometimes they give you the easy side, which is the x. You just got to plug them into the other values. Sometimes you've got to solve for the variable there. And if this was a right triangle that had a 45, or an isosceles right triangle, 45, 45, 90 triangle, same thing. So let's say they gave you this was 7. This would be a. This would be a root 2. This would be a. Then my x would be 7. 7, and my y would be 7 root 2. If instead of giving you the opposite, the 45, they gave you the opposite, the 90, this is 7, and they want you to find x and y, then this is a, this is a, this is a root 2. So I'd have to solve for a. 7 equals a root 2. 7 over root 2 would equal a, and 7 root 2 over 2 would equal a, which would be both those sides because it's isosceles. So all of that's without a calculator, right? I don't need a calculator to solve those kinds of questions. Those could be on your quiz. The 30, 60, 90, the 45, 45, 90 triangles, those could be on your quiz. The right triangle, trig ones, which I'll lead into the word problems, which we're going to see in a second, those we'll save for your test. Questions so far? Okay, then comes everybody's favorite, which are the word problems. The good news is these are not that bad. We have done them in geometry, you've done them in algebra 2, and now you'll see them again in pre-calc. So the biggest piece of information, all right, that people mess up is angle, really not angle of elevation. Most people understand angle of elevation, but it's angle of depression, okay? So when you're setting up a word problem and it says somebody's looking at something, there's an angle of elevation, it means eye level up, or if it's from the ground, it's up. So if somebody's on the top of a balcony that's up here, angle of elevation is from their eye level up, right? Which makes sense. If you elevate something, you're lifting it up, yes? Depression is what, I don't know why, but it's like something that like is so difficult for people. Depression is eye level down. So if I'm standing on a balcony, depression is from eye level down. Everybody puts it here. That's wrong. Okay, it goes from eye level down. So if I'm standing on the top of a mountain and I've got an angle of depression, it's eye level down, which is here. If you're standing on the top of a hill, if you're standing on the top of a house, if you're standing on a balcony, if a plane is flying in the air, angle of depression is from level down. And it's the thing that people end up screwing up the most. So be careful there. So obviously these are going to be word problems that you're going to have to set up, and then you're going to have to solve using right triangle trig. So this one says an irregular blue shape is a pond. The distance across the pond A is unknown. To find the distance, the surveyor took the measurements shown in the picture. What's the distance across the pond? So this one already gives you the diagram and everything. If it wants to know the distance across the pond, which is A, how do I set it up? What trig function are you going to use? Tangent, right? That's opposite and adjacent. So I would say the tangent of 24 equals A over 125. And this time, the variable's in the top, so I multiply, and I get 125 times the tangent of 24 degrees. And what mode is my calculator going to be in? Degrees. Very rarely will you see a word problem not in degrees. I guess it could happen, but it's pretty rare. So this gives you that A is 55 point, let's round to the nearest tenth for now, 0.7, and it gave you a measurement, which is feet. Questions on that one? Okay, last one. A building is 21 meters high and it casts a shadow 25 meters long. Find the angle of elevation of the sun to the nearest degree. So angle of elevation of the sun can be found a lot of different ways. From the building up, which could be here, or from the ground up, which is most common. Okay, so even though it's elevation of the sun, it's saying what would be the line, if I drew it straight up to the sun, what would be the line that makes with the ground, okay? These are actually corresponding angles, so they would be the same, so it doesn't matter which one you use. But it says the building is 21 meters high, which is what this measurement is. It casts a shadow, which is 25 meters wide, which is this one. And again, this time I'm trying to find the angle. So this is different from everything we've done so far because we don't have the angle. I still set up a trig function that's still opposite and adjacent, which means tangent. So a tangent of an angle that's unknown equals 21 over 25. So this is the button over the tangent that we haven't used yet. When we are looking for an angle measurement, we do the inverse trig function, not reciprocal, but inverse. So we do the tangent of -1 of 21 over 25. You do not change the actual ratio, so it stays 21 over 25, but I do the inverse trig function, 21 divided by 25. If it was sine of theta equals that, then I would do sine negative 1. If it was cosine, I would do cosine negative 1. And this is 40 point, well, it says nearest degree, so 40 degrees. So if we're looking for side length, then we're using the original sine, cosine, tangent buttons. If we're looking for an angle, then we use the sine negative 1, the cosine negative 1, or the tangent negative 1, whichever one is given. Questions on any of the stuff that we covered today? So the only other thing I'll review with you is there's some triples that you're going to see. So Pythagorean triples are 3 numbers that always work together to form a right triangle. Okay, and that is 3, 4, 5, 6, 8, 10. These are the most common ones. 5, 12, 13, 7, 24, 25. There are more than this, but these are probably the most common. Which means if I get a right triangle that has 2 of those 3 sides, I obviously automatically assume the third is what's missing. Pay attention though, because if it gives you that like a side is 3 and the hypotenuse is 4, the leg is not 5, right? It's got to make sense that the biggest side has to be the hypotenuse.